Okay, Mtwana, good morning, good to see you again. I'm Mr. Good, Trigonometry Revision. It's me now. Please sit down and watch the television. Don't forget to subscribe, post and comment and share. That's all that you're just going to be able to watch him to see more videos. Alright, today we're just going to look at what's in the Trigonometry Revision. Then what I'm going to do, I'm just going to explain to you the introduction or the application that is needed to you, so that you're just going to able to attack this trigonometry. All right, I'm not going to be fast as much as I can, but I'm just going to do this little bit by bit, so that you're going to understand this chapter as it is. All right, then first is first, what is important is that on the trigonometry on your exam is just going to contribute plus or minus 40%, 40 marks. All right, therefore we normally say this trigonometry is going to be plus or minus 40 marks. All right, therefore it's very important to make sure that you're gonna get 35 marks. So just going to work out on this 40%, you need to get only 35 marks. All right, how are we going to get 35 marks? Because here on the trigonometry, we normally say that we have 5 parties. All right, therefore that means when we are just talking about we have 5 parties, is whereby we are just going to look at a different question that are on the trigonometry. All right, that means if you are just having 5 parties, that means each question you need to get 8 marks, not 8 marks, only 5 marks. Only 5 marks or 6 marks, because 6 times 6 is equals 36. Okay, then that is all about the marks allocation that is needed to you. All right, therefore as you see here, we're just talking about the trigonometry. This word trigonometry, it means that you're just going to look at only 3 things. All right, therefore as you see, we have trig. Means 3 trig ratios, which is sine and cos and also tan. You know this. And also trigonometry is whereby you normally say that you're just going to look at what's in the graph. Okay, and also metra is whereby we are just going to look at a 3D shape meter. This way is just refer to a graph, and also trig ratios, and also in the 3D shape, because 3D shape we normally calculate the length. All right, then today we're just going to look at part 1 of a trigonometry. Then I normally say that when I just doing the summary of this chapter, we have only 5 parties on the trigonometry. Part 1 we normally say that is whereby we are just going to look at the definition of each trig ratios on the Cartesian plane. Then part 2 is whereby we are just doing prove identity and simplify identity, is whereby we normally say that is the part 2, how to prove the identity is very important. And also part 3 we normally say that is whereby we are just going to look at a general solution. It's very important to note that we have a general solution here. Then part 4 is whereby we are just the 2D shape and also 3D shape. All right, that is part 4. And part 5 is whereby we are just the trig function. All right, today we are just going to look at part 1. Then tomorrow you carry on doing part 2 and part 3 until we finish. All right, make sure that you subscribe so that you're gonna see the next videos. All right, let's start with part 1. Okay, we have part 1. Part 1 we normally look at a definitions, the definition of a trig ratios. All right, therefore on the part 1 is that we are just about the definition. The definition is whereby we normally say that we are just going to look at the definition of sine, and also the definition of cos, and also tan. Okay, when we are just about the definition, it is whereby we normally say that is whereby we are just going to look at opposite of hypotenuse, adjacent or hypotenuse, and also opposite over adjacent. Therefore we call those at the definition of each trig ratio. Therefore in right hand, we normally say that the definition of each trig ratios is whereby we are just SOHCAHTOA. Okay, SOHCAHTOA is it is the SOHCAHTOA is whereby we are just going to look at the definition of what? Of each what? Trig ratios. All right. Therefore, we normally say this is sine. Sine is equals to opposite over hypotenuse. This is cos. Cos equals to adjacent over hypotenuse. Tan is equals to opposite over what? Over adjacent. These are the definition of what? Of a trig ratios. Okay. Therefore, what is important is that the definition of each trig ratios, we are just going to get them only if we are just what? Only one what? Triangle, which is what? A right angle triangle. Is very, very important to note that since each definition of a trig ratio, we are just going to get them only if we are just wanting a right angle triangle. Remember, a right angle triangle is a shape that of what? Is a shape that of what? 90 degrees, as you see. Therefore, we normally say that we are just having what? A right angle triangle, as you see. All right. Listen carefully. Listen carefully. On the right angle triangle is very, very important to fill out what? The angles inside. And also is very, very important to fill out what? The length outside. Okay? How? We have only what? Only two theorems that are needed to you to know it exactly as you are. Know it exactly as you are. Then, like the first theory is that it's very, very important to note that inside the triangle, the sum of angles they are equals what? 90 degrees. They are equals to what? The sum of angles inside the triangle, they are equals to what? 180 degrees. Therefore, as you see here, we normally say that angle A plus angle B plus angle C is equals to what? 180 degrees. Therefore, we call this the sum of angles in a triangle. But as you see here, we have what? We have A, which is beta. We have A, which is beta, and also have theta, and also have angle. We have 90 degrees angle B, and also angle theta, which is angle C, which is gonna give you what? 180 degrees. Okay. Therefore, we come out with a conclusion that the sum of these two unknown angles, the sum of angle beta plus angle theta is equals to what? 180 minus 90 is going to be equals to 90 degrees. Therefore, you come up with this rule. This rule says that if you are just saying what's the right angle triangle, the sum of these two angles, they are equals to what? 90 degrees. We call these two angles are the complementary angles. All right. Then why is it important to know this sum of two angles that must give you what? 90 degrees? It's because on the exam they're just going to give you this angle. Then sometimes they're just going to say this angle is what? It is 32 degrees. Then we're going to find these angles by using what? The sum of angles in the triangle. Is very, very important to know how to fill out what? The angle. Therefore, what you're going to do, you're going to say that 90 minus 32 is going to give you what? 58 degrees. Okay? Therefore, that means that the sum of angles now, they are end up to what? 108. 58 degrees plus 32 degrees is equal, plus 9 degrees is equal to what? 180 degrees. Therefore, the rule is very, very important to note that this angle and also this angle must give you what? 90 degrees. All right. Then after that, we have a rule that we always use to calculate what? The sides. Therefore, we normally say that we have what? The theorem of what? Of Pythagoras is very, very important. The theorem of Pythagoras, the longest side squared is equal to what? The sum of what? Shortest side squared. Then you're going to get what? The theorem of what? Pythagoras. We know this from grade 7, from grade 6, from grade 8, grade 9, grade 10, theorem of Pythagoras. Okay, therefore we know how it's work. Then that is all about the rule that we need on you when you're just doing what part 1, the definition is to know what the sum of angles inside the triangle and also the theorem of what? Of Pythagoras. All right, let's go. Then after that, here, listen carefully now. Listen carefully now. Listen carefully. Listen carefully. Going deep now. Okay? After that, we have sine theta. And also, we have cos theta. And also, we have tan A theta, we normally say that it is an what? It is an angle, okay? And the angle here, they are just divided into what? Into 6 types of angles, all right? Therefore, we normally say that we have an acute angle, a right angle, obtuse angle, and also straight angle, and also reverse angle, and also what? A revolutionary angle, all right? Therefore, then is come out now with what? A tross. A tross, whereby we normally say that is what? A Cartesian plane. A Cartesian plane that starts at what? 0 degrees, and also what? 90 degrees, and also what? 180 degrees, and also 270 degrees, and also what? 360 degrees. All right. Therefore, this angle is very, very important to note that this amount of angle is always an acute angle. Is always what? An acute angle. If the angle is an obtuse angle here, we need to reduce that angle by using what? A reduction formula. Remember, when you're just talking about the reduction formula, is whereby we are just going to look at what? The quadrant, the formula that we normally use to indicate what? A quadrant. As you know that on quadrant number 1, we normally say that we have what? Theta. Theta is an acute angle because we normally say that an acute angle, it is an angle that is greater than 0 degrees but is less than what? 90 degrees, okay? And also on quadrant number 1, we normally say that we have what? A co-function whereby we normally say that we have what? 90 minus what? Minus theta. Therefore, we normally say this is a quadrant number 1, okay? And also here we have 90 degrees plus what? Plus theta. And also here we have what? 180 minus what? Theta. These are the reduction formula that are telling us about what? A quadrant. Therefore, here we have 180 degrees plus what? Plus the theta. And also here we have what? A negative angle, and also we have what? 360 minus what? Theta. We call this the reduction formula. This reduction formula, they are just helping us to reduce an amount of angle if an angle is greater than what? 90 degrees, because we always need this theta to be what? An acute what? Acute angle. All right, let's go. Therefore, we normally say that if you just want to reduce an angle, it's very, very simple and straightforward. For example, we have an example here. We have cosine 130 degrees. Okay, reduce this amount of angle. How are we going to do? As you see, we have what? 130 degrees. 130 degrees is between 90 and also what? 180. Therefore, we normally say that this is a reduction formula that we're going to use. This is a reduction formula that you're going to use. We're going to look at what is the acute angle that you need to what? To subtract here to get what? To get what? 130 degrees. Therefore, how are we going to do that? We are just going to say that 180 degrees minus this amount of angle, 180 degrees. Then we're going to get what? 50 degrees. This 50 degrees, it is what? An acute angle that we're going to put it here on this amount of angle. Therefore, we're going to say that we have what? Sine into 180 degrees minus what? Minus 50 degrees. As you see. All right. Therefore, this is now telling you what? A quadrant. This is telling you what? A quadrant. 180 minus, it is what? Quadrant number 2. Therefore, how is sine on quadrant number 2 is positive or negative? Remember, we normally say that on the Cartesian plane, all the trig ratios, they are positive. On quadrant number 1, only sine that is positive. On quadrant number 2, only tan that is positive. On quadrant number 3, and also only cos that is positive on quadrant number 4. All students take coffee. All students take coffee. All students take what? Coffee. Therefore, Therefore, we normally say that sine is positive here, and also cos and tan is negative. And here tan is positive, sine and cos is negative, and also here is cos is positive. Only sine and tan is what? It is negative. Okay. Therefore, here as you see, we have 180 minus 50 degrees. That means that we are just going to get what? 180 minus sine 50 degrees. Okay, therefore now, do you see this amount of angle? It is now what? An acute angle. Therefore, we normally say that an acute angle, it is an angle that is what? That is greater than, this angle is greater than what? 0 degrees, but is less than what? 90 degrees. We call that other types of what? Acute what? Angle. And also here we have an theta, that we call them at the special what? Angle. What is a special angle? So the special angle in mathematics is whereby you're just going to look at what? 30 degrees, and also what? 45 degrees, and also what? 60 degrees. It's this special angle, they are just having what? A triangle. They are just having a triangle of 2 triangles that have what? The special angle. These triangles, we're going to use them only if you are just using what? A compound angle, or solving what? A trigonometry whereby we are just proving or we are just simplifying. All right. Therefore, on the first triangle, we normally say that we have 40, we have 60 degrees, and also 30 degrees, and also here we have 45 degrees, and also 45 degrees. Then this one is going to be equal to 2, and this one is going to be what? Root 3, and also this one is going to be equal to 1. And this one is normally say that is equal to 2, and this one is going to equal to what? 1. Therefore, we call this the what? The spatial what? Spatial angles, triangles. All right. Therefore, we normally say that if you are just looking what? Sine 60 degrees. Sine 60 degrees, the definition of sine 60 degrees, since this one is a right angle triangle, then you can able to find what the definition of what? Of sine 60 degrees is opposite over hypotenuse. Opposite over hypotenuse. That means that you're just going to have what? Root 3 over 2. Okay? And also sine 45 degrees. Sine 45 degrees, it is what? Opposite over hypotenuse is going to give you what? 1 over root 2. Therefore, these are the very important triangles that we normally use when we are just telling you without using what? A calculator. All right, let's go. Then now we are going deep, because this is the introduction of what? Of grade 10 and also grade 11. Yes, this is the introduction of grade 10. You need to know this for part 1. Okay, a reduction formula, and also the last one. I want to remind you, the last one, it is the equation that we normally use on the first part when you're just solving this part 1. Okay, therefore, what is that? The equation that we normally use on grade 10, whereby we normally say that you're just going to look at what? The ratio of what? Of tan theta. Tan theta, we normally say that is equal to what? Sin theta over what? Over cos theta. It's very, very important to note that. Then tan theta is equal to sin theta over cos theta. That's the ratio. That whatever you see tan theta, you're going to change to what? Sin theta over cos what? Theta. All right, let's go. And also another equation that we normally use, where we normally say that is the square what? Identity equation, whereby sin squared theta plus what? Cos squared theta is equal to what? Is equal to 1. Okay, this identity have a perfect squares of what? Of identities. How, teacher? Since this one you can simplify like your sin squared theta equals to 1 minus what? Cos squared theta. Therefore, this is a what? A perfect square. Now this can be simplified, open by 2 brackets, then minus what? Cos theta, my plus what? Sin squared, sin cos theta. Like this one. This other perfect square. Can simplify this one, and also you can simplify this one. Sin squared cos squared theta equals what? 1 minus what? Sin squared what? Theta. Therefore, you can open 2 bracket also here, minus what? Sin theta, 1 minus plus what? Sine what? Theta. Okay, therefore these are the a perfect square. You can factorize like this one because we need to know this factorization because sometimes we are just going to use it when you're just proving. All right, then the last one here on the part 1. Then we normally say that we need to know what we have a compound angle. The compound angle of what? Of sine. The compound angle of sine and also compound angle of what? Of cos. We normally say that here we are just having what? U sine A times what? U cos B plus what? U sine B times what? U cos A. All right. Therefore, that's the formula that's on the formula sheet. And also a compound angle of what? Of cos. Compound angle of cos, we normally say that the sign is just going to change. Therefore, we normally say that we are just having cos, and change the sign. Then we have sine, and cos. Then change the sign, sine. Then sine cos. Don't change the sign, sine cos. Okay, therefore we know it's on your formula sheet. You need to know this compound angle, how it's going to work here. I'm going to show you. All right, and also here we have the last one whereby we normally say that you're just going to look at what? The double angle. The double angle of sine, the double angle of sine. The double angle of sine, we normally say that equals what? U sine x times what? U cos x. It's very, very important to know this is a double angle equation of what? Of sine. Then and also the double angle of what? Of cos. The double angle of cos, we normally say that of what? Cos squared x minus what? Sine squared x. All right? And also 1 minus what? 2 sine squared x. And also what? 2 cos squared x minus 1. These are the equations that we normally use on what? On part 1 when you're just solving what? The sum. Okay? Therefore, let's go now. Let's go quick. Then how can you see on your exam? This is part 1 now. We're going to grade 12 now. Grade 12, listen carefully now, okay? Then how we're going to see this is part 1 on the exam now. How we're going to see this is part 1 on the exam. Then what we're going to do here, we are just going to see only if your question starts with what? If sine 32 degrees equals to m. If sine 32 degrees equals to m. Then after that, what they're just going to ask you, they're just going to say express the following what? Trig ratios. Express the following trig ratios in terms of what? In terms of what? M. All right. Then what we're going to do here, then the first thing we need to understand with this instruction that is in front of what? If. Okay, this instruction is just telling you, or it's just directing you, go and draw what? Your A diagram. That A diagram must be what? A triangle. Remember, we normally say that you are just having what? A rough paper here. On your rough paper, then you draw a truss. That truss must have what? A 4 quadrant and 8 diagram. Quadrant number 1, quadrant number 2. Then here we have sine 32 degrees, okay? Sine 32 degrees. Therefore, sine 32 degrees, we normally say that is just on quadrant number 1 because these 32 degrees, it is an acute angle. Remember, here on the quadrant number 1, we normally say that of what? An acute angle. Therefore, we have 32 degrees as you see. Triangle, okay? This right angle triangle, we normally say that we are just going to construct the right angle triangle is going to be perpendicular to the values of y of x, not to the values of y. Is very, very important to note that. Remember the first introduction, I said that it's very, very important to fill out what the angles inside, okay? Therefore, what is this amount of angle? Then we're going to say 90 minus 32, we're going to get what? 58, okay? This is going to be what? 58 degrees, all right. Then here, what we're going to do here, we are just going to come back and look what the definition of what? Of sine. The definition of sine says that opposite over hypotenuse. Therefore, when I'm just dividing m by 1, therefore, I'm just going to get what? opposite over what? Hypotenuse. That means that the opposite side here is M and the hypotenuse side is what? Is 1. When you're just here at 32 degrees, what is the opposite side? The opposite side is what? It is M, the value of Y. And also the hypotenuse side, it is always opposite to 90 degrees. Therefore, that is the hypotenuse side. Then we have a line here and also have a line here, but we don't have a value of X here. Then now, we are just going to use what? The theorem of Pythagoras to calculate what? This amount of what? Of angle. Therefore, R squared is equal to what? X squared plus Y squared. Therefore, we normally say this is a what? A theorem of Pythagoras. Okay, let's substitute. We have 1 squared equals what? X squared plus Y m squared. Therefore, X squared is equals to 1 minus what? M squared. Then you put the square root on both sides. Therefore, X is going to be equals to what? 1 minus what? M squared, okay? Then which is what? Positive, okay? Since here it is on the positive quadrant, therefore the values of X are positive. 1 minus what? M squared. Therefore now the triangle is 4 now. You can able to determine what? Sine 200 and 200 and 200 and 200 and 200 and 200 and I'm just creating the sum here is 222 or 222 okay, let me say it's 222. Let me check right now. It's 212. Let's say this is 212, okay? They are just asking you to determine sine 212 degrees, okay? Then what you're going to do here, we are just going to say that since this amount of angle is not here on your triangle, then what you're going to do, we are just going to reduce this amount of angle by using what? A reduction formula. As you know, that is 212 is on quadrant number 3. Okay, then what you're going to do, we are just going to say 200 and 212 minus 180. Then minus 180, we are just going to get what? 32 degrees. Okay, this 32 degrees is an acute angle that is need to add it. Therefore, we are just going to say that we have sine into 180 degrees plus what? Plus 32 degrees. Okay, as you see. All right. Then now we have a quadrant number 3. Sine on quadrant number 3 is what? It is negative sine. Then we have what? 32 degrees. Okay. Therefore, and go and look at the definition of sine 32. A definition of sine 32, it's opposite over hypotenuse. Then you're going to say that we have what? Negative m. Okay. Since this one, we also give you on your statement that sine 32 degrees is equal to m. Therefore, we're going to get what? Negative m. Okay. And also we have another one that just saying that determine cos 58 degrees. Cos 58 degrees, how? It's very simple because we have an angle that is equal to what? 58 degrees. You don't need to reduce this amount of angle because it's on what? On your diagram. Therefore, what you're going to do, we're just going to look at what? The definition of cos. What the definition of cos here is going to be equal to adjacent over hypotenuse, adjacent over what? Hypotenuse. Therefore, we're going to say that is m over what? Over 1, which is going to give you what? M. Okay, adjacent over hypotenuse. All right, let's go. Then after that, we have another question whereby we normally say that, you are just having what? Cos 58 degrees equal to m. Then sometime the question is going to come, determine cos 64 degrees. Cos 64 degrees, what you're going to do here, we are just going to look at what is the angle. This angle, it is an acute angle. You cannot reduce this angle. And also, if you are just separating to 90 degrees, we are just going to get what is the angle that is not on what on a triangle. As you see, we have 90 minus 64, we're going to get what is 26. This 26 is not here on what on your diagram. Okay, that means that you cannot able to reduce this angle. After that, what you're going to do, we are just going to look at what is the angle that is inside the triangle that you can multiply by 2, or we're going to what? Add by a special angle to get what? This amount of angle. How? Then we're going to say that if I'm just dividing 64 degrees divided by 2, I'm just going to get what? 32 degrees. This is a 32 degrees that is here. That means that now we're just going to say that we have 2 times 32 degrees. Therefore, now it's come out with what? A double angle. Do you see what? A double angle now of what? Of 32 degrees. Then here you can change this one to any what? Equation, because it's just question 1. Okay? Therefore, we're going to say 1 minus what? 2 sine squared what? 32 degrees. Then after that you have 1 minus, you substitute of 2 into sine 32 degrees is opposite over hypotenuse, which is going to give you what? M all squared. Therefore, we're going to say that we have what? 1, 2, and what is squared. Therefore, after that, that is what? Cos 64 degrees. Therefore, that is a double angle. You change this angle to what? To the double angle. Okay, and also we have the last one. Sometimes we're just going to say that we have what? Cosine 2 degrees. Cosine 2 degrees. Do you see whether this amount of angle it is smaller or less than to the angle that I here on the what? On the diagram. What you're going to do here if you're just saying what? This smaller amount of angle. Okay, it's very simple. Then we always say that if an angle is smaller, we always use what? A compound angle. Alright? Therefore, what is a compound angle? The compound angle is whereby we are just going to take out all your special angle, you link with what the angle that are inside the right angle triangle. Then we've got 30 degrees, and also 45 degrees, and also 60 degrees. Okay, let's go. Then as you see here, we are just having 60 degrees. Then if we are just saying that 60 minus 58 degrees, do you see we are just going to get what? 2 degrees. 60 minus 58 degrees is going to get what? 2 degrees. Okay, that means the common angle of what? 60 minus 38 degrees. And also you can say that you have 30 minus 32. 32 minus what? 30. Then you're going to get what? 2 degrees. Therefore, do you see the special angle they are working on what? On this what? This angle that we have. Okay. Therefore, you can change by using 60 and also 58, and also you can change by using what? 30 and also 32. How? We're going to say that we have sine into 32 degrees minus what? Minus 30. Therefore, we are just going to get what? 2 degrees. Then after that, this is a compound angle of what? Of sine. We know that when we are just talking about what? The compound angle is whereby we normally say that we are just going to look at what? Sine 30 degrees times cos 32, sine 32 degrees times cos 30 degrees, and minus sine 30 degrees times cos what? 32 degrees. Then after that, we're going to do, you're going to substitute. Sine 32 degrees is equal to what? Opposite over hypotenuse. Opposite over hypotenuse. Therefore, what is the opposite side here? It is what? It is n. Hypotenuse side, it is 1. Therefore, times cos 30 degrees. Remember the triangles that I taught you that we have a triangle that has what? A special angle of what? 60 degrees, have 30 degrees, and also 2, and also 1, and what? Root 3. Then when I'm just looking at what cos 30 degrees, it is adjacent over what? Hypotenuse. Therefore, we're going to say that what? Root 3 over 2 minus. Okay, and also here sine 30 degrees is here on a triangle. It is opposite over hypotenuse 1 over 2. Then of time, cos 32 degrees is here. It is what? Adjacent over hypotenuse is going to be equal to what? Root 1 minus what? M squared over 1. Then after that you multiply. This one time this one is going to be equal to what? Root 3 over 2m, then minus this one is going to be equal to what? Root 1 minus m squared over 2. Therefore, the denominators are the same. You take one denominator, then you add what in the numerator. We have what? 3 root m minus what? Root 1 minus what is m squared. Then after that, you leave your answer like this one. Then it's what? is side 2 degrees. Okay, therefore that is all about what if question 1. Okay. Question 1, we're just going to see question 1 by if. Okay, then let me do the last one whereby they are just giving you what the restriction. The restriction is very, very important to know that we're party the restriction where the right hand triangle we're going to draw. Okay, now, all right. The restriction, let's start with what is the restriction first. Okay, a restriction is whereby we're just talking about what in the inequality sign, and also whereby we're talking about what is the round bracket, where they are just giving you the direction of what of theta. Okay, how? Like this is an example that of what's the restriction. Okay, if they are just saying that if 2 sine theta equals to root 3. Okay, then after that I'm just gonna say that where theta is an element of what of 0 degrees is to what is to 180 degrees. Then close bracket. Then after that they're just going to say and where cos theta is less than what is 0. Then after that, I'm just going to say determine without using a calculator. Determine without using what a calculator. Determine without using a calculator. The following trig ratios. Okay, the following determine without using a calculator the following trig ratios. Okay, all right. Then what we're going to do here, then for example here we have a restriction. This is a restriction, and also this is what a restriction. How can you say this is a restriction? Is the restriction they are always written in the form of what bracket, and also square bracket, and also they are always written in the form of what inequality sign. Okay, this one you can write as theta is greater than 0 degrees, but is less than what 180 degrees. Okay, if you don't want to write this restriction in the form of what bracket. Okay, and also if you are just about the square bracket, we normally say that when the restriction is look like this one, having a square bracket, we are just having a show that we are just about quadrant 1. Okay, we are starting at 0. This is 0 degrees, 90 degrees, 180, and also at 270, and also 360 degrees. Okay, therefore here they are just saying that the angle theta is going to start at 0, not exactly at 0. It's going to start approximately at 0 degrees. Then it's going to end approximately at what? At 180 degrees. Okay? That means we're just talking about what? 2 quadrant here, quadrant 1 and quadrant number 2. Okay? And also here they're just giving you the restriction. Where cos theta is less than 0. Where cos theta is less than 0. Cos theta here, all the trig ratios are positive. But cos theta here is what? Is negative. Therefore, that means these trig ratios, we are just going to draw what in the right hand triangle on the second quadrant, because is where cos theta is what is negative. Okay? But when you're just saying what in the square bracket, when they're just saying that here, where what it is the element of square bracket to 0 to 90 degrees, they're just saying that exactly at 0 is going to start exactly at 0 and also end exactly at 90 degrees. Then sometime they're just going to say that x is going to be what? Less than or equals to what? Less than, greater than 0 or equal. If they are just putting equal, is same as what is square bracket. We are just having a show that it's going to end at what? At this what? Is going to start at this angle and end what? At 90 degrees. Okay? Therefore, the restriction, they are just guiding you where you're going to draw what your diagram. As you see here, we are just having what? Quadrant number 2. Why is quadrant number 2? Is because this restriction is just telling us what 2 quadrant from 0 to what 180, quadrant 1 and quadrant number 2. But where cos theta is less than what? 0. When the trig ratio is less than 0 is negative. Therefore, it's negative from quadrant number 2. Then you draw your truss. You draw the truss. The truss must have what? Your arm on what? On quadrant number 2. Therefore, you construct it. It always must be perpendicular to the values of x. Therefore, you go and simplify this ratio and look at the definition. As you see, opposite over hypotenuse of sine. Therefore, we're going to say that the vertical sine theta, you divide by 2 on both sides, is equal to what? Root 3 over 2. Okay, therefore, what is an opposite side here? What is an opposite side here? It is what? It is this side is root 3. What is an hypotenuse side? Is 2. Okay, then after that, we left with what? The value of what? Of x. Remember, the angle must be full inside. Then since here we don't have an amount of this angle, what we're going to do? We normally say that this angle plus this angle must be give you what? 90 degrees. Therefore, that's why we normally say this angle is going to be what? 90 minus what? Theta. Okay, let's go. Then here we are just going to use what the theorem for the chorus to find what this what that side. Then we're going to say that if r squared is equal to what? S squared plus what? Y squared. That is what? A theorem of Pythagoras. Then what's the value of x? The value of x you are looking for, the value of r, it is what? 2 squared. Then the value of x, we don't know. Then the value of y, it is root what? It is root 3. Then no squared. Then after that, we have 4 equals to x squared plus what? 3. Plus 3, yes, plus 3. Then x equals to, then you take this one, you put on the side, then 4 minus 3 equals to 1. Therefore, that means that the square root of 1 here is going to be equals to what? Is going to be equals to what? Is going to be equals to negative 1. Here, we are just having what? Negative 1 because you are on the second what? Quadrant. That's why it's very important to draw what? Your Cartesian plane. Don't draw what? Your triangle. Some of you are drawing triangles. I don't know what. But you're gonna understand it. I don't know how. Okay, let's go. Then now we have the value of x now, which is negative 1. Okay. Then what we're going to do here now, we're just going to able to determine what? Sine theta times cos theta. Cos theta, which is gonna be equal to what? Which is going to be equal to what? 1 over 2, what is sine 2 theta. Okay, let's go. Okay, listen, I'm just thinking about the sum here. Okay, here, what's happening here? Then I'm just going to ask you, determine 1 over 2 sine what? 2 theta here. That's the other question, okay? As you see here, we're just saying what? 1 over 2 sine 2 theta. Therefore, here on the diagram, we don't have what? 2 theta. Then what we're going to do? We are just going to say, okay, this is the double angle of what? Of sine, okay? Then what we're going to do? We're just going to say we have 1 over 2. Then of what? We have 2 sine theta times what? Cos theta. Then after that, 1 over 2 times 2 is equals to what? 1. Then we'll have to do what? Sine theta times what? Cos theta. Then you come out with a solution now. What's the definition of sine theta here? It is what? Opposite over hypotenuse is going to be equals to what? Root 3 over 2 times. What's the definition of cos theta? It is what? Adjacent over what? Hypotenuse. Negative 1 over what? Over 2. Therefore, after that, you do your math. 1 root 3 times 1 is going to be equal to negative is going to be equal to negative root 3 over what? Over 4. Therefore, this means it's equal to what? 2 sine 2 theta. Okay, I just created the sum. All right. Therefore, it's very, very important when you're just proving. And know that if you're just having 1 over 2 sine 2 theta, is always equal to what? Sine theta times what? Cos theta. Okay? Therefore, that is another rule that I'm giving you. That is Mr. Curtis' rule. This is Mr. Curtis' rule, this one. This is Mr. Curtis' rule. Then make sure that if you are just having 1 over 2 sine, double angle of sine, then it's always equal to what? Sine theta times what? Cos theta. Therefore, after that, you can able to what? To solve what theta, because here we're doesn't have what 2 angles here, okay? Then after that, that is all about what The first part of a trigonometry is whereby you're just looking at what the Cartesian plane and also the precision is very, very important. Precision can be written in a form of inequality sign and also bracket and also square bracket, and also the trig ratios can use the trig ratios to find the precision. All right. All righty, okay. Then tomorrow we're going to look at part 2 when you're just proving this up. Thank you. Please don't forget to subscribe, please.